So in the previous video, we talked about how to set up a the project, right? And before we talked about how to set up the project, we talked about how to do some system settings, right? So if you go to the file menu bar and you can sort of set up the system, the software, you can configure how the software, the Petrel software actually works in the system settings, right? We looked at some of the options inside of this particular menu item. And then we started to set up a new project, right? And we looked at this project settings, right? In particular, we looked at how to choose a coordinate, right? Coordinate system, and then how do we actually set up some of the options that's used quite often, right? And we looked at some of the capabilities for configuring the units in your project, right? By using a customized unit, right? That kind of thing. And then we started to import some of the wellhead data, right? The wellhead data into our project. We created a new project. We set up the CRS, the coordinate system, and then we started to import wellhead data into the project space, and we started to examine those wellhead data, right? And we looked at how to actually configure the display, right? The display of the wellhead of the wells, right? We looked at the style tab. Right? Underneath the style tab, we have path, which controls, for example, the thickness of the well path, right? And then the symbols, right? How big the font is, how big the symbol size on top of the well path is, that kind of thing, right? And so those are some of the basic things about how to set up a project and how to import wellhead data, right? And at this point, if you would like to save your project, for example, if you would like to save your project, what you can do is to actually click on the save button, right? Save project button. You also can use the keyboard shortcut, which is Control S. Let's try to save it. Let's try to save it. And then if it's the first time you're saving the project, it's going to ask you to pick a location, right? Pick a location in your current file system. And then let's just put it on my desktop, and then let's call it demo or my demo. And you can sort of see save as type. So Petrel has several data types. The master project file is going to have a .pet in its file name, right? So suppose I save it. And then I'm going to go to the desktop and take a look at the files that's been created. Okay, so now it has finished saving the file. Let me minimize the window, and then let's take a look at what's actually on my desktop. So you can sort of see there's a my demo here, right? And if you examine the property of my demo, you're going to see it's of type of file .pet, right? It's a .pet file. That's sort of the master file for every project. So every project has only one .pet file, right? That's the master file. The master file is going to record how the project was set up, and it's going to contain links to actual data, right? And where is the actual data is going to be stored, right? The actual data is going to be stored in another file that's called a PTD file. The PTD file is not really a file; it's actually a folder, right? And if you open it, you can open it and take a look at what's actually inside of it. It's just like an ordinary folder, ordinary file folder, right? But it's got lots of things inside of this folder, right? most of the files and most of the folders are only used by the .pet file. So when you actually open a project, the .pet file will be able to actually link to those internal files and folders that's inside of the .ptd folder. So every project is going to have a .pt file. And then that .pt file is more like a master file that actually has links to lots of the data that's stored in the .ptd folder. The ptd folder is going to actually store the data that's sort of related to that project, right? For now, the data is pretty small. It just contains the wellhead data and some setup information, right? But later on, once we add, for example, seismic data, and then as we add more and more data, this folder is going to be used to actually either store the data or store links to the disk locations of those very large files, right? So .ptd file is used internally by Petrel itself. So these two files are very, very important, right? And you have to sort of protect this .pet file. That's sort of the master file. That's the key file. If this file is damaged in any way, you may have to sort of redo the entire project, which is a huge waste of time, right? So this file has to be backed up, has to be protected by all means. And this .ptd file or data folder, this folder is the data folder, right? If some of the files in this folder is damaged, you can still repair it, right? So that's still okay, but you don't want to sort of damage the .pet file. And then when the project is active, when this particular my demo project is active, you're going to see a third file that's called a .lock file, lock file. And this .lock file, the meaning of it is that when I am actually editing this particular project, when I am doing stuff on this project, then other people cannot make any edits. If they also have access to the PET file and to the .ptd file, they can open the project, but they may not be able to edit this particular project. Their changes won't be saved because you who are editing this particular file earlier is going to have the lock on this particular file. So it's going to prevent this particular file is going to prevent other people. It's going to prevent other people from doing stuff to this project simultaneously as you are working on that project. So this lock file is basically just a file that prevents other people or prevents multiple people from editing the same project at the same time. So the file is kind of always synchronized. It's not going to be sort of out of sync because different people are editing on it at the same time, right? So those three files. But if you actually closed your project, if you have closed the project, you have done all your things, you have closed Petrel, you have closed the project, or you have started working on a different project, then this .lock file in your folder is going to disappear. And then if someone else opened this particular object in their own computer, then they have a .lock file. So this .lock file is going to be unique, right? So if you are editing on it, then you are going to have the .lock file. But if you are not editing on it, but other people are editing on it, then this .lock file is going to be obtained by other people, right? And this .lock file on your computer is going to disappear. So basically, these three files, the folder, the .ptd folder, the .lock file, and the .pet file, all of those files are kind of important. You have to sort of pay attention to it. And sometimes you may want to back up your .pet file and the .ptd folder to a different location or something, right? If you have done a substantial amount of work on it, right? Okay. So now let's we have saved our files. Now let's try to sort of import more data, right? Import more data. So the next set of data that we're going to import is actually the well path data. Right. For now, the well path is assumed to be vertical, right? But in practice, it's never true, right? It's not like every well is like a completely vertical. It could have some angle to it, and the well path could sort of snake around underneath the ground, depending upon how the well is being drilled, right? So that's called the file that we're going to try to import is called the well deviation file, right? It's called well deviation file. The way for importing those well deviation files is kind of similar. It's kind of similar to how we actually import the well head data. So right click on it, right click on the wells folder, right? The wells folder. And then what we have to do is to import on selection. Again, click on import on selection. Right. This time the files of type has to be sort of changed from well headers to well deviation file. So well path deviation. Right. We have to select this particular option. So well path deviation ASCII star. Right. Once we have changed the files of type, you're gonna have more options now, right? So sometimes so here in the type column, you're gonna see two types. DEV file, those are the files that we want, right? And then you still have other files, for example, last files, right? Those files are well log files. Well log files, we'll import those files later on, but for now, let's just look at the DEV files, right? If all your files are kind of mixed up, the different so suppose I sorted according to name, for example, right? And then all the DEV file and all the last file are going to be mixed up, right? So DEV file and then last file and then DEV file. This kind of organization of the files is going to prevent you from using the shift key to select multiple files at the same time. If you want to select multiple DEV files, you have to hold down the control key and then click, right? And if you have lots of wheels, this kind of a single click can be kind of tedious, right? So in this case, what you can do is to just sort according to type. If you sort according to type, then all the DEV files are going to be clustered together. In this case, you can just use the shift key. So you click on the top one, and then hold down the shift key, and then click on the last one. Then you have selected all the DEV files, right? And then at this point, you can just click on open. And then it's going to give you this dialog box. And this dialog box is called what? It's called a match file name and well. The reason that you are seeing this particular dialog is because you have imported the wellhead data for like this bunch of wells inside of your into your project, right? So Petrel actually has a record of all the well names that you have imported, and now you are importing the path deviation file, right? So what Petrel is going to try to do is to try to match those path deviation files to the well head data, to the wells that you have already imported. So it's going to try to do a match for us. And this is the match that it came up with, right? So basically, Petrel is just going to look at the file name and then try to sort of match the file name with the well name that you have already imported, right? So now you can sort of see it's actually doing a pretty good job matching up all the files, right? There's no error at all, right? A10 matched to A10. So file name, this first column is actually the file name of the deviation files, the path files. And the second column is a well trace. That's the well name that you have already imported into your project. Right? So you can sort of see a parenthesis after every well name, right? For now, it's empty. The reason that it's empty is because when we imported the wellhead data, the wellhead file does not contain the UWI, the unique well identifier, the UWI. The wellhead data doesn't have the UWI, right? If the wellhead data does have UWI, then those UWI are going to be displayed inside of those parentheses, those unique well identifier, right? But for now, it doesn't have it, so it's empty, right? Now let's click on cancel first. Let's click on cancel first, and then let's go back to the file system. Let's go back to the file system and let's make some changes. Where's that file? Where's that demo file? Demo data. Okay, demo data. That's inside of here. Where's my well data? Wells, right? That's wells. So all my deviation files are like here, right? It's from here. Suppose I change A10. I change the file name of A10. I change the file name A10 to A10 path, wheel path or wheel path, right? I change the deviation file for the wheel path data for A10 to A10 underscore wheel path, right? That I've changed the path name. And let's see if Petrel can still actually match up all the different files with the wheels, right? Again, let's import again. Import on selection, right? So this time it's a wheel path deviation, right? And then let's just select all the DV files. All the DV files, right? And then let's open. Again, we are seeing the match file name and a wheel, right? But is Petrel able to actually match A10 underscore wheel path with A10, with the wheel trace A10? No, it's not, right? So it's not intelligent enough to actually sort of tell this particular file name actually matches up with A10, the wheel trace A10, right? And it's giving you a choice for create new, but we don't want to create a new. We don't really want to create a new. We want to select from the existing wheel trace. So we click on it, and then it's going to give us a choice selection. So it's A10, right? So it's A10. Let's select A10. All right, so A10 underscore wheel path, this particular deviation file is going to be matched with wheel trace A10. But this wheel trace A10 is selected manually. It's not automatic, right? When you actually try to import data in your actual project, you must pay attention to if they are actually matched up, right? And if they are not matched up, you have to manually select the wheel trace for you to actually match the deviation path file. Now we can click on OK. And now we're seeing another dialog box, which is basically asking us to specify the format of this particular of all the deviation files, right? Again, Petrel has this kind of very nice thing which allows us to examine the content of the deviation files from the bottom pane, right? So this is actually a view into the first 200 lines of A10 underscore wheel path, that particular deviation file, right? That's the first 200 lines of that particular file, right? So we can see the content of those files. Those files are all ASCII files, right? We can also open them in the notepad and look at those content in the notepad, right? But that's the content. That's the content, right? So again, we see those line numbers here. So the line 1, line 2, and the colon are all added by Petrel. So the actual content of the file are the text that's after the colon, basically, right? So the line number is added by, and the line number and the colon are added by Petrel. So we can sort of look at the content, right? So at the beginning, we have some sort of description about the data, right? That's called the metadata. It's a data that's describing other data. So that's called metadata, right? And then we're going to see the actual data. So again, we're going to see the head of the different columns, right? So MD is what? MD is the measured depth. That's the depth along the wheel path, right? If the wheel path is different from vertical, if the wheel path is not exactly vertical, it has some angle, then MD measured depth is going to be different from the true vertical depth. But MD is the depth that's along the wheel path. It's inside of the wheel, basically, right? And then X, Y, right? That's every point. That's the easting and northing in our CRS, in our coordinate system, right? In terms of meters for every point in our wheel, on our wheel path, basically. And then that's Z, X, Y, Z, right? That's a coordinate. Right? Z is also in terms of meters. For every point on our wheel path, it must have a easting, northing, and a vertical coordinate. And then this is the true vertical depth, right? Dx dy means what? Dx dy means it's the deviation from the wheel head in the easting and northing direction, right? How far the point on the path deviates from the wheel head, right? So for the first point, the dx and dy is 0, which means that this is exactly the wellhead, right? But for the next point on the well path, you have some non-zero values, right? So it means that in the easting direction, it has deviated 0.1, and then in the northing direction, it has deviated minus 0.017, this kind of value, right? And then azimuth and inclination angle. So azimuth is sort of the angle with respect to the north direction, right? And then inclination angle is the angle with respect to the vertical direction, right? So for example, as you drill a well, the drilling bit, the head of the drilling bit is going to have an azimuth with respect to the north, and then an inclination angle with respect to the vertical direction, right? So for every point along your well trajectory, you're going to have these two angles, right? It's the azimuth and inclination angle, right? So every point on your well path can be uniquely determined by a few of those columns. So all those columns actually are redundant. You don't have to sort of, for example, if you just have x, y, and z, then you can fix the well path, right? Right. You don't really need all the other columns, right? All the other columns are just redundant. And if you also only have MD and azimuth and the inclination angle, if you just have these three columns, you can also uniquely determine the well path, every point on the well path, right? On the path. You don't really need x, y, z, or true vertical depth, that kind of thing, right? And if you only have true vertical depth and dx, dy, you can also uniquely determine every point on the well path. So those different columns are kind of a redundant. It has lots of redundant information in it, and Petrel is actually intelligent enough to detect that. So it allows you to actually specify to use just a selection of those columns, right? So if you try to you can try to use MD, inclination angle, and azimuth to determine the well path, right? So the default choice is actually measure the depth and then inclination angle and azimuth, right? But you can also select the dx, dy, true vertical depth, or xy, or true vertical depth, or just xyz, that kind of thing. You have a different choice here, right? The default is MD, inclination angle, and azimuth, right? It's selected here. And if you actually selected this particular choice, you have to tell Petrel which columns are MD, inclination angle, and azimuth. In our file, the first column is MD. Those line numbers in the front and the column doesn't count as columns, right? Those are added by Petrel. The actual file actually is starting from after the column, basically. So MD is going to be the first column. So MD is the first column, right? Is that right? Right. And then inclination angle is the ninth column. The default is giving us the ninth column. Is it the ninth column? 1, 2, 3, 4, 5, 6, 7, 8, 9. So inclination angle is indeed the ninth column. And the azimuth angle is the eighth column. That's eighth column, right? So the column numbers figured out by Petrel automatically is actually correct, right? So suppose we select dx, dy, and TVD, right? Then we have to tell Petrel which column is dx, which column is dy, and which column is true vertical depth. So dx, the automatic value is 9. Is that correct? No, it's not correct, right? It's 1, 2, 3, 4, 5, 6. Dx is the sixth column, right? So if we want to use dx, dy, dz, TVD, we have to change dx to 6 and dy to 7, and then true vertical depth to 5th, right? It's 1, 2, 3, 4, 5. True vertical depth is supposed to be the 5th column, right? But let's just go back to the default. Let's just choose MD, inclination angle, and azimuth. These three columns can uniquely determine the entire well path. And then the true vertical depth elevation reference, that's calibration, right? KB value. We specify that in the wellhead data already, right? That's and then other settings, we don't really have to change anything. And then that's the input data, right? We also have a settings tab. Extend well trace at top, at the bottom. We don't want to do that. We just want to use the actual well trace. We don't want to do any kind of extensions. and then coordinates and units. So by default, it's going to use the coordinate system that you picked for your project when you actually set up the project. That's ED50, UTM31 that we used already, right? But if the file that you are importing is using a different coordinate system, is using a different coordinate system from the coordinate system that we set up for the project at the beginning of the project, then you can click on other CRS and pick a different pick a coordinate system that's sort of applicable to the well path deviation files, right? So for our project, true north and grid north doesn't really have a difference because the grid north is true north, and then units meter, right? And then angles are degrees, right? Those angles are degrees. It's not radians. And this well is offshore, right? All the wells are offshore. We looked at the in fact, this is actually in the North Sea. This particular well field is actually in the North Sea, so it's actually offshore. If it's offshore, then the reference vertical depth is close to sea level, right? So everything is kind of below sea level, right? Everything is below sea level, and that's pretty much everything that we want to sort of look at, right? So for this particular data set, we're looking at the offshore choice, and then this time we are not just importing one file, right? We're importing for like 10 files, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, or 15. We're importing like 15 files, right? If we're importing multiple files at the same time, we have to click on OK for all now. If we're just importing one file, then OK and OK for all has no difference, right? But if we're importing multiple files, if we click on OK, then we're going to see this dialog box for like 15 times. But we don't want to sort of do that, right? If we click on OK for all, it's going to apply all our choices to all the 15 files at the same time, and then we can just import all of them in just one batch. Right. So after we have finished importing the well path and deviation files, the 3-dimensional display is going to look like that, right? So we can sort of see the well actually has some kind of angles to the vertical depth. So it's not purely vertical. It's got some kind of shape, right? It's got some kind of shape. And if we go to the input pane, right? Now the wells that we have imported now has some kind of data that's associated to it, right? So suppose we right click on one of those wells, right? And then in the context menu, we can sort of detect some kind of spreadsheet, right? If we choose the spreadsheet item, we're going to be able to actually see a spreadsheet for the well path. Right. So when we actually imported the data, we only used the MD, inclination angle, and azimuth. We only used these 3 columns, right? But you can sort of see there's a lot more columns in the spreadsheet. In fact, those X, Y, and Z, and also dx, dy, and every other column that you're seeing here are all computed from MD, inclination angle, and azimuth automatically by Petrel, right? So Petrel can actually automatically figure out what are the corresponding values for X, Y, Z, and other things, and other kind of other columns. So it can automatically compute it, right? Because you can actually figure out X, Y, and Z from MD, inclination angle, and azimuth. You can compute it. You can compute X, Y, and Z, and also the deviation values, right? And then true vertical depth. You can also compute it, right? And for now, the two-way travel time, or TWT, is empty, right? We haven't actually looked at the check shot data or seismic data yet, right? If we have seismic data or check shot data, we can sort of have a velocity model. So two-way travel time is what? Two-way travel time is so in seismics or in seismology, the time and depth can be converted back and forth from each other by using something that's called a velocity model, right? So if you know the velocity along the path, then you can convert the distance, or in terms of depth, vertical distance, you can convert depth to time by just dividing the depth by the velocity above that particular depth, right? And then if you know the velocity model and you know the time for traveling to that particular interface and get back to the surface, right? Traveling from the surface to that particular depth and then gets back. If you know the two-way travel time, you can also compute the depth of that particular interface, right? So once you know the velocity model, time and depth becomes mutually convertible, right? You can convert depth to time, time to depth. So this two-way travel time can be computed either from true vertical depth or some MD, or right. You can convert from a depth to a two-way travel time if you know the velocity model. But for now, we don't have a velocity, so that's why Petrel cannot actually compute the two-way travel time yet, right? And anything else for us to look at right now? So let's just close it, right? So that's how you actually import the path file, right? How do you actually import the path file? So after you have imported the path file, the wheel trajectory is going to look correct in 3D, right? You also have a two-dimensional window, right? And this two-dimensional window are going to automatically be updated, right? So now you can sort of see some of the tails, right, following the head symbol, right? The wheel head symbol. You have a small tail following it, right? You have a tail following it. So now you can. That's because the wheels are not exactly vertical. If the wheels are actually exactly vertical, then you will be able to. You will be able to sort of. You won't be able to see the tail, right? So now the three-dimensional objects looks more complicated, right? And let's take a look at some more buttons. That's going to allow us to look at three-dimensional views of those different kinds of objects, right? So the first thing I want to say is that on the top, you're going to have a new context menu, right? So if the window is active, you're going to be able to see a pink context menu item. It's a tab, basically. If you click on it, it's going to display all the relevant buttons, all the buttons that are relevant to 3D views, to this particular 3D window that's active, right? So suppose we have like two different windows, right? A 3D window and then a 2D window. So if we make the 2D window active, right, and then you can sort of see automatically this 3D becomes 2D. Right? Did you notice? So then that's all the buttons that's related to two-dimensional graphics, 2D windows, right? So depending upon which window is active, now it's going back to 3D. You're going to see lots of more buttons that's related to 3D windows, right? And then 2D, it's going to go change all the buttons inside of it, right? Right. So right. So you're going to be able. So some of the buttons are actually similar to the buttons that's displayed here, right? So on this toolbar, you're going to see a bunch of buttons also, right? And so some of the buttons displayed in the ribbon are going to be sort of a duplicate of the thing here, of the buttons here, right? So for example, we have the big eye, that's view all, right? If you click on it, then it's going to bring all the objects into view, right? Into the view. And sometimes when you actually look at lots of three-dimensional objects, you're going to lose orientation, right? You may lose orientation. You may forget about which direction is north, that kind of thing, right? And then you have this button, right? The default behavior for this button is view from above. So if you click on it, it's gonna sort of change the view, change the perspective to change the viewpoint to be exactly vertical from above. Right. So now the x-axis is here, y-axis is here. Z-axis actually points into the screen. Right. That's the depth axis, and then north points to up in the screen. So that's north, right? And then this button actually has a choice. If you click on the inverse reversed triangle here, right, you can choose from view from above, view from below, for example, right? If you choose view from below, then you are looking. So then you are looking from the bottom of the box, right? So if you look at the arrow looks red now, which means that you are looking up from the depths, right? You're looking towards the sky. So sky is going to be sort of into the inside of the screen, right? So you are looking from below, right? And then you also can sort of change your viewpoint, view from west, for example, right? View from west, then that's going to give you a view from the west direction, right? So the arrow is going to sort of look like that, right? Right. So right, that's looking from west. So north is in that direction. So the arrow is actually pointing what the north is in this way. Goes to my left. That's the north, right? And then view from east, right? And then view from south, and then view from north, right? And then if you want to sort of keep focus, right? Keep focus. Let's still change it to view from above, for example. Let's still change it to like view from above. And that's this particular button, right? That's it. And there are also other buttons that at some stage will become useful, right? If you think that this compass is kind of annoying, you can sort of turn it off, right? If you click on this thing, then the compass is going to go away. And this compass button is not on this particular quick access bar. It's not on this graphical bar, right? But let's still put the compass on. The access button is also duplicated here, right? You can, if you like a particular view, you can try to export the three-dimensional graphic into an external file, and then you can show that file to your manager, and then give it to your colleagues, that kind of, right? So that's the two-dimensional windows, right? That's the two-dimensional windows. That's the three-dimensional windows, and all the buttons that's associated with it, right? So we have looked at how to import wellhead data and well path data, right? So now let's look at how we can actually import well log data, right? So again, right click, right click on it, and then again import on selection, and this time we're going to import well logs. The well log files have a standard file format that's called LAS file, right? So we can just select them, and then for the files of type, it's not going to be well path deviation files anymore. It's supposed to be well log data, right? So you have you have like three choices for well log data. So well logs ASCII star, well logs DLIS star.dlis, and then well logs LAS last file star.las, and all the files that we are using in our this kind of demo project are last files, right? So let's just pick the last one. So the dot start of last file, right? That's going to be our format. But what I can tell you is that if you use the more general format, for example, Willog's ASCII start of star to read the dot last file, it's also going to work, right? So Petrel is actually intelligent enough to actually recognize it. So if you just import, if you here you select Willog's ASCII, it's also going to work, right? It's also going to work. But let's still use the last file because it's kind of a sort of a format that's kind of fixed for Willog's specific. I mean, those are files that's kind of specific for Willog's. So let's click on open. So again, it's giving us a dialog box, match files and wills, match wills by using will name. Yeah, let's use will name. We don't have UWI, so let's, and then will name based on last header. Let's use last header, right? Okay. We can also use the file name actually. We should. So let me do a cancel here. Let me do a cancel and then redo it. Right. Let me import on selection. Right. Willog's last open. Right. So will name based upon, is it last header or is it going to be file name, right? So for the file name, we have, so the different files that we have looked at, the file names actually is matched with the will name, right? So if we don't want to use the file name, the will name that's inside of the last header, we can just pick a file name here. But in the last header, in the header lines of every last file, it's also going to contain the will names, right? So let's just use the will name that's inside of the header lines of each of the last file, right? Let's click on OK. Then it's going to give us this kind of very large dialog box. It's kind of very large dialog box, right? So so we've got like three different tabs, right? Data, settings, and then log attributes. The most important tab is basically just the data tab, right? So the default behavior is that it's going to try to create new logs. The reason is that we don't really have any logs. We don't have any existing logs in our global will logs folder. So the thing that I forgot to explain is let's still cancel it, right? So for now, the global will logs, if you click on it, it's empty, right? It's got log attributes, but it doesn't have actual logs, right? Those log attributes are kind of some kind of placeholders, right? It doesn't really matter. But the global will, inside of the global will logs, you have no logs actually. You don't have any logs, right? And then for the attributes, for the will attributes, you don't really have a log information in it either, right? Those are kind of will head data and will path deviation data, that kind of thing, right? So there's no logs. There's no logs, right? But if we try to sort of import on selection and then select all the last files or the log files. Oh, sorry, click the wrong button. And then open. And then OK. So the default behavior is that Petrel knows that you have no will logs in your will data right now. So the default behavior is that it's going to try to create new logs and then load all those log data into those created new logs. Right? It's not match existing logs because you don't really have any existing logs, right? And then we have a third choice that's called specified. Right? Let's click on specified. Let's click on specified. Once you clicked on specified, and then everything underneath it is gonna become editable. You can change it. If you just click on create a new, then everything is grayed out. You don't really have the freedom to make any changes, right? So now let's click on specified. Right. Once we click on specified, we can choose, right? So again, global will log, it's gonna create a new regular log. That's kind of the default behavior, and that's also the behavior that we want, right? If that's not what you wanted, you can click on this arrow, and then you have sort of create a new time series lock, that kind of thing, right? For now, you don't really have a choice for adding to existing or match existing logs, right? Because there's no existing logs, right? But if you have existing logs, then you're going to have a new option item that's called match existing logs, right? But for now, it's not. And then you have a log name. Those are the names that's corresponding to the header, corresponding to the column names in the log file, in the last file, basically. So it's not really displaying it. Can I actually make it longer? Right, so each of the last file is going to have a bunch of columns, right? And some of the columns are going to be have names, right? So maybe it's a good idea to just look at those text files, maybe. So A10, last file, right? Let's open it. So we've got how many columns? We've got like 1, 2, 3, 4, 5, 6 columns, right? And then in the header information, all those lines that's kind of above the data, it's going to tell us what kind of logs they are, right? So the first column is going to be depth has a unit of meter. Perm, that's permeability, right? Permeability. It's supposed to have a unit for permeability, but it looks like it's not exactly correct, right? And then gamma ray, right? So depth, permeability, gamma ray, right? So the first column is depth, the second column is permeability, the third column is gamma ray, and then the next one is the next column, the fourth column is porosity, and then the fifth column is going to be fluvial phases. Fluvial phases. It's supposed to be integers, 1, 2, 3, 4, that kind of thing, right? Right. For now, I only see like 1, 2, 3. Okay, 1, 2, 3. I don't see a 4 or 0. I see a 0. So 0, 1, 2, 3. It's like a sort of discrete values, right? And then the last one is the net to gross. That's the net to gross ratio, right? If you don't really know what the net to gross ratio actually means, it's not really too difficult to understand. It's you can sort of Google about it, right? But it's gonna take a while for me to explain it. But for now, it's not important, right? Let's just that's sort of the content. That's sort of the content. So Petrel is actually intelligent enough to recognize those different log names, and then it's gonna match a log name with a property template. So it's going to try to match fluvial phases to phases, right? So if that's not the right kind of a property template, you can sort of click on this triangle and then try to find, see if we can find fluvial phases. No, it doesn't have fluvial phases. Okay, but in a previous version of Petrel, there's a choice for fluvial phases, right? But it's not difficult to actually recreate a new one. You can just create a new template for later on, right? But for now, let's just accept phases. It doesn't really matter too much. And then unmatched, right? Unmatched means what? Means for this particular log, it was not able to find a proper sort of property template, right? So net gross. Suppose see if we can actually find. No, it doesn't have net gross either. So it looks like, so if you press N on your keyboard, it's going to bring you to the first occurrence of the property that with a starts with N. But later on, we can sort of try to create our new templates, right? And yeah, I think that's everything that we would like to sort of look at on this particular dialog box, right? So for example, for gamma ray, right? The unit in the file is incorrect, right? But the Petrel actually recognize what's supposed to be the correct unit for example, for gamma ray, right? And then for permeability, it also changes to millidarcy. That's correct, right? Porosity, right? So Petrel is actually intelligent enough. If the unit in the file is actually wrong, it's going to give it the right unit, right? The correct unit. Settings, log attributes. Those things we don't need to change. Let's just click on OK for all. Right. It's going to take a while to import all the data. It's not really big data, but my computer is relatively slow, so it's going to take some time to import it. Okay, so now if we look at the global well logs, we now have a yellow rectangular box in front of it, right? And then if we click on this triangle in front of it, then we're going to see the logs that we just imported, right? Fluid physics, gamma, permeability, porosity, net growth, right? So suppose we want to look at the porosity, we can just click on this porosity yellow box in front of it. See? And then all the porosity are displayed together with the well path, right? And for one of those wells, B1, it doesn't really have any logs, right? If we look at the B1, yeah, B1 doesn't have a log in front of it. You don't see a triangle in front of it, right? But for A10, for example, you're going to see well logs, see? Right? If you want to see the porosity for all the wells, right, you can control it from the global well logs, right? You can display multiple ones. So here you are displaying porosity and permeability together, right? So those yellow boxes are some kind of attributes, right? Some kind of attributes. Those yellow boxes, those gray boxes are just objects, three-dimensional objects, right? And then if you actually click on those boxes in the global well logs, it's going to control the display of the well logs on all wells, right? But suppose you don't want to sort of look at the porosity or permeability for all logs, for all wells, then you can go to individual wells. For example, if I go to like a B9, right? B9, and then B9 has a subfolder that's called well logs. And inside of this well logs, you're going to see all the different logs that you just imported. Suppose I want to see permeability for just B9. Then only B9 is going to display its own logs, right? And then porosity, right? So it's gonna you'll be able to actually see the logs just for B9, right? Let's turn it off. And at this point, you might want to sort of click on a save to just save the progress of your project, right? And yeah, I think that might be enough for one video. So let's stop here.